Okay, let's look at this question here. The question is find the QDR given the coordinates of NDB. So the NDB A coordinate is given as 35 degrees north and 63 degrees west. It's there in my notes. Question number 36. Right? Now, the coordinates of the aircraft is also given as 35 north. Are you guys with me? The streamers? Yes? Yes, Paurnami, can you hear me? Right, guys, if you have trouble, do let me know, because I'm not really used to how we have been in the other classes with the other ground school, but I'm sure you can actually catch up. If you have trouble with the online system, let me know, because I can see your chats over here. All right? Do you have it? Okay, yeah, so the aircraft coordinate is 35 north and 43 east. Perfect. Now, you're given the variation at the NDB as 10 degrees east, and variation of the aircraft is 15 degrees east. Perfect. Now, let's very quickly do that. I'll give you some time, 2 minutes, go through it, and then we'll do it together. All right. Thumbs up. I'm glad that you have a good number of answers coming up here. I can still see some wrong answers. Let's find out why. All right, so pretty much clear that we're looking at the NDB system here, right? Let's draw the diagram with NDB and the aircraft in position. We can see the coordinates given, and for that reason, we are kind of drawing it on a chart or on the globe, right? So let's draw that. So we have the NDB and aircraft. What can you tell me about their positions? The coordinates here, that's it, they are on the same parallel of latitude 35 degrees north, right? So let's draw that. Northern hemisphere, 35 degrees north parallel of latitude. NDB A is on 63 degrees west and aircraft is 43 degrees east, kind of on both sides of the prime meridian. Let's draw that now. 63 degrees west and we have 43 degrees east. Let's mark the points here. So NDB is at the intersection of 35 north with 63 west. So NDB is right here. So I'm drawing the symbols repeatedly. You have to have an idea about how it looks on the chart as well. This is how you would find the NDB on the chart. All right. Now the aircraft is at 35 north and 43 degrees east. Yes, that's here. Right, the heading of the aircraft is not very significant here, because what is asked in the question is to find out the QDR. The QDR is basically the track from the station, magnetic track from the station, from the NDB. Let's draw the aircraft for the sake of drawing it. Let me put the aircraft on a heading of this somewhere around 300. I hope you understood how I found it is 300. I'm just a random value, but that should be around 300 here. This is 270, that should be 300, right? Perfect. As I said, we don't generally draw the heading and stuff on a chart because it's more to do with the tracks and stuff. All right, you're asked to find out the QDR. And what is QDR? Let's kind of deduce the definitions here. QDR. QDR is point number 1, it's magnetic. Point number 2, it's track. And point number 3, it's from station. So basically, it's the NDB here. It's from the NDB, magnetic track from the NDB. What can you find from here? You can find out again the track from the station. Let's find out the track from the station, that is this one here. But remember, what you're going to find out is a true track because it's on the globe, and hence we have all these coordinate systems here, right? And because it's all with respect to true north pole, and true north pole, it is degrees true, right? So this is for obvious reasons. You're traveling eastward along the parallel of 35 degrees north, and therefore it is 90 degrees true, right? Now this is the true point number 1. Point number 2 is the true track, and point number 3 is again from station, which is the NDB here, and therefore the Q code is QTE. QTE is 090. That's it. This is the primary understanding which you have to have. Do not take this as QDR, which is asked in the question. This is not QDR, it's from the chart, therefore it's QTE, right? Now, how will you find out QDR from this? It's a very straight conversion. You have to apply the variation. Now, if you have the previous theory in mind, which variation will you apply for an NDB system? It's a variation at the aircraft, not the NDB, right? This is where few of you went wrong because you took the variation at the NDB still, right? So variation at the aircraft, which is right here, which is given in this question as 15 degrees east. Do not take the variation at the NDB. You can kind of try this out straight in the question because NDB systems, we're looking at variation of the aircraft because the ADF measures the QDM, which is at the aircraft, right? So the QDR is basically track from the station. We apply variation of 15 degrees east. So true east variation, magnetic is going to be least, therefore we have subtracted 90 degrees minus 15, which is 75 degrees. Now it's magnetic. This is the track from the station, which is 75 degrees magnetic. Let's see what the aircraft gives us. So what the aircraft gives us always is the QDM, either directly in the form of an RMI, or you kind of add it up with RBI and heading, and you find it if you have an RBI in the system. So at 75 degrees, how will you find the QDM? So we have QDR. QDM is reciprocal of that. So basically, you can either add or you can subtract 180. Right, so it is 55 degrees, again magnetic, and this will be your QDM. And this is what the aircraft would give you. So aircraft is going to give you, the RMI is going to give you the QDM. If your aircraft has an RBI system, I know I'm going a bit off in this question, but it's always worthwhile going through multiple concepts here. If your aircraft has the RBI, you won't be getting this directly. You have to deduce it using a heading, which I have roughly taken as 300 here. If your heading is 300, if your QDM is 255, I will leave it for you. Find out what your RBI reading would be. All right, so we have the NDB. I've kind of taken off that the Earth concept here because we're looking at magnetic values here, and now we know what the track from the station is, which is QDR, which is 75 degrees, or you even have the QDM, which is 255, track to a station, magnetic, right? So let's draw that track straight away, which is 75 degrees magnetic. That's somewhere around here. This is 75 degrees. It's a good practice to draw the QDM as well, which is 255 degrees. And now we have the aircraft here, and in that previous scenario we have taken a heading of say 300 degrees, so let's keep it like that, straight here. Okay, now we are going to find out what the reading of the ADF would be if it was an RBI. So let's draw the dial. This is the best way to kind of answer this. We have done these questions numerously before. I'm not explaining it much here, but just draw a dial over the aircraft, and you know the ADF needle is always going to point towards the NDB. It is least bothered about your heading. That's it, right? So it's going to just point towards something. Hey, the NDB is right there. That's all, right? You have to find out what this is going to be, right? If it is an RMI, its head is going to be the head is over here. The head is going to be the heading of the aircraft, and hence it's going to give you the QDM straight. If it's an RBI, which as in this case, its head is going to be 0, right? And what it measures is the relative bearing from the nose of the aircraft clockwise all the way to direction in which your ADF needle is pointing. But I have left it completely for you. Expect you to have the answer. This is just a basic explanation for the streamers right here. You have to find this out, right? So you just basically have to find this, right? So what is the QDM? QDM, which is the magnetic track to the station, is basically your heading plus your RBI, and therefore RBI, relative bearing indication, is going to be QDM minus your heading. You can even find this from the diagram, but since most of you are fresh batches here, I don't want to kind of confuse you with it. So QDM minus yeah, but you must have forgotten that, right? Do you remember this? Right, that's it. So all your long ground classes in US is kind of floating, I know, but that will definitely help you. So QDM is basically 255, that's right here, minus the heading, assumed heading is 300, it's in the previous diagram, and that's going to give you 135, sorry, 315, let me see, 255 minus 300, which is minus 45. And we don't have minuses here, so basically minus 45 is 45 degrees in the anti-clockwise direction towards the other side. That is 360 plus the answer, and that is 315. this is the relative bearing, degrees relative. So this is going to be 315, which is going to be indicated in your RBI. Right, so I'm not kind of reducing that. This is basically the QDM, and therefore what the RBI is going to indicate is 315. So if you have a dial here, let me draw a dial as well very quickly before we kind of wind up. So that this is how the pilot would be seeing it, and we have the aircraft at the center, and for an RBI, it's going to be 0 degrees as the head of the RBI. If it's RMI, it's going to be the heading, and the ADF needle is going to point towards 315, which is right here. You've kind of take this diagram all the way, kind of tilt it in such a way that the aircraft is facing this side. You can see the needle is going to be like this, the same diagram all the way here. And this is 315. This is going to read 315 here, provided this is an RBI. If it's RMI, it's going to read 255. All right, that's it. Now we'll wind up for today, and I think we're done with the entire VOR system as well. You'll have a test paper on this